Okay, more review. Section 1.11 starts with significant figures and decimal places. You've seen this before. We have a number with a lot of places behind the decimal point, and they ask us to round it to 3 decimal points. Okay, so we start at the decimal point and we say we can have 3 places behind the decimal point. So we can have this 1, 2, 3. This is how many we're allowed, right? So we want to get rid of these, but we need to look at the first number behind the line that we drew. If this, if it is 5 or more, yes, if it's 5 or more, we round up. If it's less than 5, so 4, 3, 2, 1, 0, we round down. This is 5 or more, so we round up. So this 2 turns into a 3. So 6.343. Because this 29 is closer to 30 than to 20, right? So we want the 3. Okay, this one, round to 2 decimal places. Start at the decimal point, count to 2, 1, 2. This is how many we're allowed. Look at the next number behind the line that we drew. Is this 5 or more, or is it less than 5? Well, 2 is less than 5, so we round down, which just leaves the 0. 1.30. We rounded down, so the 0 stays a 0. Because when you look at this bit, 0, 2, is that closer to 0 or to 10? It's closer to 0. So we want the 0. Okay. Now, another way of rounding, in a way, is rounding to a number of significant figures. Now, you need to know that a significant figure is a non-zero number. These are 5 non-zero numbers, right? Say they want us to write this with 3 significant figures. Well, we start on the left and we start counting when we hit a significant figure, so a non-zero. This is our first one. 1, 2, 3. So this is the last significant figure that we're allowed to have. Now we don't want to change this 62,934 into all of a sudden 629, right? We need these places. We need these to be zeros. So we put zeros in for these 2 numbers, but we also need to look at this first number behind the line that we drew to see if we round down or up. This is a 3, so it's lower than 5, so we round down. So nothing changes to that 9. So we still have 6, 2, 9. We rounded down, so the 9 stays a 9. And we replace these 2 numbers with zeros. Okay, let's do this one. We're allowed 2 significant figures here. So we start counting on the left, or we start looking from the left and we count the significant figures. These are all zeros, so not significant, not significant, not significant. This is the first significant figure, the 4. So 1 and 2. This is how many we're allowed, right? Leaving these numbers out does not change the value of this 4 or of this 7, right? Because we have a decimal point and this 4 is in the 10,000ths place. And even if we leave these numbers out, this is still in the 10,000ths place. So all we need to figure out is whether we round down or up. So we look at the first number behind our line. Is it 5 or more? Then we round up. If it's less than 5, then we round down. Well, since it's 9, we round up. So the 7 changes into an 8. So let me write that, 0.0004, and the 7 changed into an 8. And we don't replace these numbers with zeros because that doesn't change anything to the number, right? Because we're behind the decimal point. Okay, another one with a decimal point. 3 sig figs is what we're allowed to have. Start on the left. This is the first one. 1, 2, 3. So we draw our line here. 2 is less than 5, so we round down, so the 0 stays a 0. Now in this case, our last and third significant figure is a 0. We have to write that 0. If we write this, and people ask us how many significant figures are written here, we'd say 1, 2. But we wanted to be precise enough by giving 3 significant figures. So we do need to put that 0. And it tells us that that our answer is more precise than if we would write this, right? We've got 3 significant figures here. I should add one to show you that even a 0 can be a significant figure when it's in between or at the end. Right here, the 0 is significant. In this case, if I were to ask you how many significant figures this have, you would count from the left to the first significant figure that you hit, the first non-zero. Right, I should say, so the first significant figure in your number is the first non-zero number, right? Boom, that's the first one, that's the second one, third one, fourth one. So this has 4 significant figures, even though this 0 is a 0, right? It's between the other numbers, so it's significant. Okay, simplifying onto something completely different. Simplifying algebraic expressions. At times you'll be asked to simplify expressions. We've got this here. Simplifying is something we do by collecting like terms. See how there's an x squared there and there's an x squared here. These are like terms, and we want to put them together. So x squared minus 4x squared, we've just put them together, right? Then we have a negative 6 and a plus 15. We've just put the loose numbers that don't have a variable with them, we've just put those together as well, right? Now we can combine them, because we can subtract 4x squared from x squared, right? That gives us a negative 3x squared minus 6 plus 15, that's plus 9, right? And that's our answer right here. Okay, another word you need to understand is expansion. Sometimes they'll ask you to expand. You'll have an expression and they'll say, please expand. Expanding means you I can't think of the word. 7 times 5a plus 6 is actually 7 times 5a plus 7 times the 6, right? So expansion is just getting rid of the parentheses, right? 7 times 5a plus 7 times 6, which is 7 times 5a is 35a, plus 7 times 6 is 42. So this would be the expansion of this expression. Okay, sometimes they'll ask you to expand and simplify. So we first do this getting rid of the parentheses, expanding, and then we'll have to do some kind of simplification by collecting like terms. Let me show you that in this expression. First, expansion, right? 3x plus 3 times 4 is 12, minus 2 times x minus 2 times negative 5, which is positive 10. And negative 2 times a negative 5 is a positive 10, right? Now we collect like terms. We're going to add the x's to the x's, and we're going to add the loose numbers to the loose numbers, which gives us 3x minus 2x is 1x, right? Plus 12 plus 10 is plus 22. So we've just expanded and simplified. And this is much better looking than this big long thing.